You've had this material that's been around forever and there's still so much to learn, you know. Even just the historic material, how it works and the chemistry involved is so complex. And that's not even considering, all of the new things that are happening. Hi, and welcome to this month's episode of Engineering Greatness, an original podcast series produced by the American Concrete Institute. I'm Lori Tunstall, assistant professor at Colorado School of Mines in Golden, Colorado. And with me today is Jialuo.
Hi, I'm Jialuo He, and I'm a research assistant professor at the Department of Civil and Environmental Engineering at Washington State University, Pullman, Washington.
Welcome to the podcast. Let's begin by discussing, Jialuo, how did you arrive at your career path? What brought you to civil engineering to start? How did you pick your original university for your bachelor's degree?
Sure,
Walk me
sure,
through that, what that looked like for you.
sure. That's a great question, and it's a long story. Actually, I obtained my bachelor in polymer materials in 2013, and then I decided to come to the US for my PhD. So I first got admitted to Illinois Institute of Technology and started my PhD program in chemical engineering, actually, there. And then after 1 year at Illinois Tech, I just got the news that Professor Dr. Xianming Shi at Washington State University would like to hire a PhD student with the background in polymer synthesis for the research of self-healing concrete. So I said, yeah, why not? I would like to go and expand my area of research. So I moved to Washington State University for my PhD program. And during the PhD program, I mainly studied the development of two self-healing systems for the concrete. And after I graduated from Washington State University, I started my 1 year postdoc appointment at Drexel University, mainly studying the protecting mechanism of a sustainable bio-based concrete surface protectant. And then after working in a small engineering company in Maryland, Beltsville, Maryland, for almost 10 months. And then my PhD advisor, Dr. Shamish, just asked me if I would like to uh, return to WSU to help him because uh, he got a national UTC center here based in Washington State University. So I said yes. So I moved back to Washington State and started the role of assistant director of the UTC National Center there. So after about 2.5 years, uh, my PhD advisor he moved to University of Miami, so I took over the role of director of this national center, and currently we are wrapping up it. And yeah, and then I got promoted to research assistant professor in last June, mainly
Congrats.
continuing with the all the research that we are doing
That's
previously.
great. So your introduction into concrete materials was pretty natural because you already had a materials background.
Exactly.
You're just extending it from polymers to a new material
Mhm.
type. How has that been for you? Because those are pretty different materials.
Exactly, exactly. So basically for polymer materials thing, um, most of the universities got their polymer um, categorized under the Department of Chemical Engineering. So during the first year of my PhD program at Illinois Tech, it's mainly about doing the synthesis of some drug delivery system, things like that. So yeah, and I'm more focused on the thing of materials itself, like the mechanical properties, things like that. And I think when I got the news of some professor, my PhD advisor is looking into the self-healing concrete with some interdisciplinary properties, I'm thinking that yeah, that's a good opportunity to expand my knowledge, things like that. Because I'm always I'm a person who always would like to seek some challenging things like that. And yeah, so that's why I'm trying to expand my knowledge, and also I've never been to West Coast, so
Yeah, now you've gotten to go there twice now.
exactly.
That's kind of fun that you've gone full circle back where you started.
Yeah, yeah.
Yeah.
It's a long journey.
Yeah. What are some of the challenges, or I guess opportunities that you see that you're excited about with self-healing applications in concrete?
Well, when I first started the research of self-healing concrete in WSU, so we spent a lot of time, actually almost a semester, reading all these articles and papers to decide which direction exactly should go. Because basically there are two two types of self-healing system. One is biotic, the other one is abiotic. So to be honest, I don't have too much background in biotic thing. And after reading a lot of biotic research, biotic-based self-healing concrete, um, so I feel it might be a little bit more comfortable with the abiotic thing. So because it's mainly associated with the synthesis of polymer, the microcapsules, or the vascular system, things like that. So yeah, I think I could that would be a good start point for me. And on the other hand, I may need to start studying the chemistry of cement chemistry along with the concrete. So yeah, I I think that's a good direction. So I told my PhD advisor that okay, I will select the abiotic self-healing systems for the concrete, and then I move on with the two systems. One is the synthesis of uroformaldehyde microcapsules, and the other one is I selected the one that employed the lightweight aggregate along with impregnated with healing agents and encapsulated by the polymer materials. I selected PVA as the coating materials.
Well, do you feel like your background in polymer science and drug delivery and your whole life as, a polymer scientist before that gives you an advantage in these applications?
Somehow, yes, a little bit, I would say. It
Yeah.
helped me to quickly understand the synthesis process, synthesis procedure for the polymers. Because
Yeah, I find that our field attracts people from really varied disciplines. You get some people who have been, civil engineers, their whole kind of academic background. You get some chemists, some material scientists, and I think that it makes our field a lot richer in the knowledge we can bring to it when we, collect the knowledge base from all of these different backgrounds and combine it for some novel applications. I think that's where we have a lot of the advances today.
yes, indeed. Yes, indeed. And also I think interdisciplinary background is becoming increasingly important now for a professor. I mean, for especially junior faculties, because yeah, because well, I think yeah, that's that. So I mean, for me, it's always been happy and exciting to seek challenging things or challenging topics. Well, not I would say somehow relevant, but still need to step out our comfortable zone to expanding our expertise and knowledge, things like that. It will
Mhm.
pretty helpful for the growth of a junior faculty.
Yeah. How long have you been involved with the ACI?
I attend the ACI convention in 2017 for the first time, the
Okay.
one in Anaheim. yeah, it was a great experience because yeah, as a student, the registration fee is pretty low. I mean, pretty reasonable,
Yeah.
and it feels great to because the atmosphere and the environment is pretty I would say comfortable. And actually, I made a lot of friends there, and I just noticed that some other PhD students or newly graduated PhD they also attending, and their expertise is in self-healing and concrete as well. So I kept talking with them by asking a lot of questions that I've encountered during my research. So yeah, it was very helpful, and yeah, we became good friends for a very long time. So we usually met once or twice a year during the ACI convention. It's a very, I think it's a very good and productive event for us. So yeah, Laurie, I'm also curious that what inspired you to studying civil engineering, especially the concrete materials.
Yeah, I feel like my whole path was, I don't know, lucky or it was a very windy path for me. I actually started my undergraduate degree as an English major. I thought that maybe I wanted to go into law. I really enjoyed writing and communication, and yeah, and I thought that that would be a way to make a difference. But when I was taking the courses, I really missed my STEM courses. And so I started looking into different minors that I could maybe do with the English major. And honestly, it was just through Googling like different minors that involved like physics, which I really liked in high school, that I discovered engineering. And then I looked at the, different engineering disciplines, and civil engineering seemed, um, I don't know, one of the most impactful to me. So that kind of got me on the path of civil engineering. It was a kind of a really random path that I'm really feel very lucky that I found, because it's been a really rewarding career path for me so far. Um, and then I had some internships that were interesting, but I never liked them as much as my coursework. And so that made me think that maybe I wanted to be a professor and actually teach the courses that I loved so much as a student. So I started exploring graduate programs, and was really found myself really attracted to the research areas that were focused on concrete materials. So I didn't really have much exposure to material science before that, but that's really what I found that was kind of drawing me in. Every, civil engineering research field that had focus on materials is the ones that I found most attractive. So I found a program at Princeton, which was my top choice, and I was lucky enough to have an open position and get selected for that. And that's when I really got involved in the material itself. So yeah, kind of a random pathway that I feel really lucky to have found and have really enjoyed studying concrete since. I think what attracted me to it is you've had this material that's been around forever and there's still so much to learn. Even just the historic material, how it works and the chemistry involved is so complex. And that's not even considering, all of the new things that are happening. So yeah, I just found the whole field very fascinating.
Well, that sounds really impressive to me, you know. So yeah, that's such a huge and such a huge conversion from the English background to
Yeah.
engineering background. So is that a little bit challenging for you to studying these engineering courses during I mean especially during the your PhD pro do you need to catch up?
Yeah, I
Yeah,
should
do
say
you need to catch up all these things?
I didn't explain that very well. So I did end up in my undergraduate degree, I ended up converting my minor to a major. So I stayed an extra semester to finish a full degree. And so I was kind of fully caught up on my civil engineering coursework. I once I started taking the courses, I realized that I liked that way more than the English major, and so I ended up switching over and doing the English minor instead. So I still had the civil engineering background, but despite that, I would say that it was pretty challenging in the PhD program because so much of it really required material science, and I had a very, classical civil engineering background. And then my PhD was focused in all material science. So taking thermodynamics for the first time and, different sort of physics courses and chemical engineering courses to bolster that background for the material science knowledge I would need for concrete materials. That was challenging, but very rewarding. And as you said, I think what's driven me to research is the love of learning new things and challenging myself to yeah, to just learn more and understand how things work. So it was challenging, but very rewarding, very exciting.
Exactly, cannot agree more. Yeah, so yeah, it somehow remind me of my experience of learning those pretty difficult course. I mean, at least difficult for me, especially in structural engineering, like advanced reinforced concrete design and finite element, pre-stressed concrete, things like that. Yeah, it's been a really tough time for me, but I can also feel myself like growing very fast and quickly comprehending all these things in civil
Yeah.
engineering. So yeah, so what? So I'm also curious that why do you choose to concentrate on concrete materials instead of like other materials or other topics in civil engineering?
hmm Um, yeah, that's a good question. I mean, I think the fascination with concrete itself, as I said, just like this material that's been around forever and we know so little about it still, I think that that was attractive to me. And also how much of the concrete we use, it felt like a real opportunity to make impact. If you can change something even a little bit, it has kind of worldwide impact to, all sorts of the it has worldwide impact to a broad population. It's not going to influence just a small set of people. It could influence everyone. So I think the impact is really what drew me to concrete.
Sure thing. Yeah, definitely. Yeah. Yeah, and yeah, so actually to be honest, I didn't have any experience in the student clubs during my PhD program. It was pretty hard for me to get
Oh
things done and things like that.
yeah,
So
me too.
I'm curious. Oh, I'm curious if you have ever attended any concrete I mean student clubs related to concrete like ACI student chapters or
No, I was really late to get involved in ACI. And honestly, I was so focused on my studies that I didn't really spend much time in student clubs. I always regret that in retrospect. I wish that I spend more time on, and I guess being part of the campus culture, in the clubs and in the different activities they have. But as much as I tell myself that I need to do that, even as a faculty member now, as much as I tell myself I need to participate in the culture of these communities, I end up just kind of focusing on work. That seems to be how it goes. I think the only thing that I continued in my undergrad and grad program was orchestra. I play violin. So I did orchestra for, my first couple of years, and then I got too busy in grad school. And ACI, I didn't start going to that until actually just a few years ago. I think my first one, it was in Orlando. I don't know if maybe 2022, 2023, somewhere in there. Anyway, that was my first ACI convention. I don't know about you. Were you exposed to ACI earlier?
yeah,
I was never introduced to it as a grad student, so I kind of came to it on my own when I was looking for things to get involved with as a faculty member. Did you get exposed earlier?
I attended my first ACI convention in 2017. Yeah, when I was a graduate student, and yeah, I did a presentation there. I would say it was okay. It was okay. I practiced a lot and hopefully I didn't mess up it. Yeah, yeah, I agree with you your point that we should uh, attend more. I mean, participating more student events and student clubs. I mean, me neither. I didn't attend a lot of I mean participating in a lot of student clubs here in the US. So I would say I'm kind of trying to make it up by serving as the faculty advisor of the ACI student chapter and as well as the advisor of the Concrete Canoe Club here at WSU. And yes, I really enjoy uh, guiding the students, also teaching them, and also talking to them and learning from them as a student. For example, we yeah. So the Concrete Canoe Club at WSU has been suspended since COVID, and
Oh,
so I yeah we I took over the position of the faculty advisor, and then we had a bunch of great students, especially the president and the co-president of the team. They did a good job in I mean optimizing the mix design of for the concrete canoe because we basically lost everything, every documents and everything. So we need
oh,
to
that's a shame.
start from the very beginning. And yeah, but it was really enjoyable to working with the students. Like I just kind of like feel like I'm kind of like slightly different from the course that I'm teaching, the course of core construction materials that I'm teaching. So I directly start with the mixed design of how to make the concrete light and strong as well for the concrete canoe and show them the way of doing the try and error thing to finalize the mix design of the concrete. And they truly also learned a lot and also very hardworking, made a lot of samples. I also trained them on how to do the testing from the of the aggregates as well as the compressive strengths, things like that, how the curing condition affect the stress development of concrete, things like that. So yeah, they really enjoyed it. And I think both me and the students learned a lot from this progress. And yeah, I think I will continue serving as the advisor for I mean training more students to get I mean first inspire their interest in concrete and then training them to be a good and qualified civil engineer specialized especially in concrete materials things like that.
So you're officially involved in more student clubs as a faculty member than you were ever as
Yeah,
a
to
student.
somehow
Yeah.
make up make it up for me for myself. Yeah.
Yeah, they it seems like a lot of fun. The students are. I'm actually not involved with Concrete Canoe here. That program was up and running and well functioning before I got here. But the students seem to really enjoy it and learn a lot from that experience, and honestly, just have a lot of fun.
Sure, sure. So, yeah, because so yeah, so you're an assistant professor now, and yeah, I'm also trying to seek a tenure track assistant professor position now. So, I think another question that which inspired me from the process of training the students of the student club that how's the engineering education um, seems to you, especially the courses, the mentorship of especially for the undergraduate students means to you.
Yeah, that's a great question. I think it's really important to me. What I love the most about being faculty is the research. I think that's just a lot of fun. Um, but I feel a strong sense of duty to our undergraduate students and my grad students as well to give them a good experience with engineering, to teach them and get them excited about the course content or the research, because what we do is just really fun, and it would be a shame if a poor course delivery or a bad like group culture influenced someone to think differently, because engineering is such a rewarding career. And I think our community, like the concrete community, is such a great community to be a part of. It's a really supportive. I'm sure you felt that as a faculty member as well. There's such a rich, cohort of faculty member who are focused on concrete. It's just a great community. And I want to create that kind of community for our students too, so they can see how rewarding it can be to be involved in it.
Sure thing, sure thing.
Yeah.
Yeah.
How about you?
Yeah, well, I think one of the challenge of undergraduate education, especially in concrete, is to get the students more involved in the lab session, you know. It's always a little bit challenging for me to kind of like showing the really fantastic and attractive mm, side of concrete because yeah, I have to admit that I'm not doing a very great job at keeping the lab cleaning and tidy. You know, it's always pretty hard.
Yeah.
So yeah, but when but I still do see the interest and their the interest and the I would say enthusiasm in getting to know more about the concrete when from the students, especially from their eyes, when I'm showing all those interesting small samples or big samples or all those prismatic cylinder or cubic samples with interesting materials like uh, nanomaterials or biochar, things like that, and telling
Yeah.
them, okay, how great this material is and how the service life of the concrete can be enhanced or extended by like 10 times with this new like for example the self-healing system, things like that. So yeah, that I think that's the most important part of in triggering their interest and letting them know the not only the importance and the impact of our research, but also the real value in terms of uh, uh, commercial and for I mean for the future, I would like to say.
Yeah. Yeah, I mean, I think you and I are both on the more on the concrete material science side, rather than, concrete design. I think one of the challenges to teach concrete materials, I teach a grad course on concrete durability, for example, um, is to really understand how the materials work. You kind of need to understand material science. And most civil engineering students don't have as much interest in material science, or certainly not as much background. So I think it's a tricky balance to inject enough material science to help them understand the material properties they're observing, while not making it so heavy on material science that you lose their interest, because you go too far into chemistry or something and they don't care about chemistry, they became civil engineers because they don't like chemistry, So I think that's a challenge of striking that balance.
Yeah, yes, indeed. So, yeah, I always trying to show them that okay, you're gonna become the doctor, not the PhD, the doctor for diagnosing the concrete
Yeah.
under suffering from multiple types of distresses like either corrosion or chemical attack or physical attack, things like that. And yeah, so speaking of research related to concrete, so uh, what I would say what probably maybe some aspects that you would foresee the trend of this uh, old materials to to for the next 100 or 200 years.
I'm not sure I understood. Could you ask that again a different way?
Sure. So I would say which aspect of concrete, this kind of old materials, you would foresee to be the most important for the next 100 year for the next generation in terms of like durability or and sustainability.
Yeah, that's a good question. I'm so impressed by the creativity of my colleagues. People are doing such creative things in pushing the boundaries of concrete. And I'm so yeah, I'm so inspired by it. I'm finding it hard to answer because I'm thinking of all of the different great things people are doing and
Yes, yes.
how impactful that can be for the future of concrete. I think some of what I'm most excited about, at least, is um, this idea of like multifunctionality of concrete, instead of just having it be a structural material, like what else can it do? We know that it's a
Okay,
good structural material,
exactly.
but could we make it multifunctional? Could it have um, cooling properties, for example, where it helps, regulate energy consumption in the interior of buildings or um, yeah, so I think that's kind of exciting to me, the multifunctionality potential. Um, and then I think there's this whole movement now of trying to think about concrete design, either from materials or structures, to be more sustainable. And I think that that's really pushed a lot of innovation. One of the things I came across, I don't know, maybe a year ago, was this idea of designing um, concrete structures to be able to be disassembled. So instead of kind of pouring things in place, having a prefab model where you basically like slide them over top of rebar and create a composite in a totally different way so that at the end of the life of the building, you can kind of just take it all apart and reuse all the pieces. I thought that that
Yeah,
was
yeah.
really clever. So I don't know, so many people are doing such interesting things that I think could really push the industry in a totally different direction than I've ever considered. Yeah.
Yeah, I agree with your point of multi functionality. Yes, yeah, one of my one of my uh research that I think it's pretty um I think pretty related to your point of multifunctioning is that I would regard concrete as a reservoir for a lot of things, like either for um so I'm yeah, what I'm thinking about use I mean incorporating more types of recycling materials in concrete
Hmm.
instead of just ending up in landfill. So yeah, so that would meanwhile it can also uh reduce the usage of conventional like conventional materials like Portland cement and river
Yeah.
cement and aggregates, things like that. Instead, we can keep using the keep recycling the old concrete and reuse them, and also exploring the feasibility of using more other recycled materials like recycled plastics, recycled like biochar, and which is a pretty hot topic currently. And yeah, so because a lot of things just can be turned into biochar, and we can use it in concrete.
Yeah. That's actually a big part of my research now. I'd say something like 80% of my group now is looking at biochar use in concrete. And I agree, concrete has a unique ability to store things in a way that can be beneficial. So in the case of biochar, storing carbon permanently, or at least for thousands of years, right? And avoiding CO2 emissions from biomass decomposing.
Exactly.
And our research, at least, has shown that it can actually enhance the properties of concrete too, when done under the right, considerations. And so now you have this material that can um, basically sequester carbon for thousands of years while enhancing concrete strength and performance and potentially durability as well. And so, yeah, I'm curious of how many things like this will move forward. I think I've been really, I don't know if you've observed this too, but I've really been impressed with the concrete industry over the last 5 or 10 years. I think it has a reputation for being not innovative, where like nobody wants to make any changes because there's too much risk involved. And
Exactly. Yeah.
I would say the industry has really shifted in the last 5 or 10 years to being really open to innovation. I'm not sure exactly what triggered that, but it
Yeah.
has really shifted. And
Yeah.
that's exciting to me. I don't know. Have you observed similarly?
Yes, so the industry previously they always a little bit more conservative than the academia, and I think thanks to the a lot of large companies during the past 10 or even 20 years trying to persuade the entire industry to use some uh, new materials or innovative materials like Portland limestone cement, things like that. Especially, yeah, I one of my friend in Heidelberg Materials, she told me in the ACI convention last fall in Philadelphia, saying that okay, actually the entire U.S. has already shifted to using the Portland limestone cement, and which I think is a good sign of it. Even though sometimes I feel a little bit painful to find the traditional type 1 or type 1 2 Portland cement for research because
Yeah, for
yeah.
research that's gotten challenging. Yeah.
Yeah. So, but I'm still very glad to see such shift. Yeah, that is very good. And so yeah, let's go back to the ACI. So I'm wondering how the ACI can help to advance our career in especially in concrete, probably in terms of academic jobs and also industrial jobs.
Yeah, I'd be actually curious of your take on that because I haven't been involved in ACI as long as you. For me, what's been the most valuable for my career has just been the networking piece. Now I feel like I have this whole resource pool of experts in different aspects of concrete that I can call on and ask them questions, or if I need an industry contact, maybe I don't have that industry contact, but someone else at ACI does. And it's just been really, really helpful in a way that I didn't anticipate. Um, it's, people always say, it's all about your network. And I think I always kind of dismissed that as like, it's about the quality of your work. But I think as I've progressed in my career, I've realized like how much a solid network is like a career accelerator and just it makes your work more impactful, more efficient, and honestly more fun. You have more people to bounce things off of.
Sure thing, sure
But
thing.
I'm curious of what you would say because you've been involved at, I guess, different career stages than me and for much longer than me. So yeah, how's it influenced you?
Yeah, I agree with the point that the network thing
Yeah.
of the ACI, especially the ACI conventions. And yeah, I've met a lot of people in ACI convention and also make a lot of new friends there. Keep the bonding with the old friends. Um, yeah, the story that I would like to share is that I met one of my friend when I was in Illinois Tech. He actually graduated from the chemical engineering PhD program from Illinois Tech, but we met after like 7 years. We didn't get contact with each other during the past 7 years, but we met. And then he told me that he's now working at a company manufacturing the concrete additives, which is pretty I was a pretty shock to me,
Yeah.
a great shock to me. And yeah, so he and we talk a lot about the from about concrete. He will start from his point of view of concrete additives, basically polymer manufacturing for uh, I mean enhance the workability, durability, like the superplasticizer or shrinkage reducing the mixtures, and he also introduced some innovative additive that they were developing at that time, and I was truly inspired. So I would say ACI is a very good stage for getting people connected, and not just from the academia, but also from the industry. And
Yeah.
I also heard the statement that actually the the papers, either the publications, not only the papers from the ACI journals, but also Concrete International, is one of the most one of the magazine that get most people read and access to. So
Hmm.
I would say it's really making a great impact on the concrete industry
Hmm.
for sure. And yeah, I think it's a very good stage and platform for young people, for senior people, for people from both academia and industry to get connected with, especially those technical committees on different subjects. And yeah, and also I really enjoyed um, volunteering in some of the committees, so to get to know more people from the industry, to get to
Hmm.
know the real needs of the industry.
Yeah.
Yeah,
Yeah, it's good to make sure that as a researcher, you have line of sight to the application, the people who are actually going to use it. And I think ACI gives a lot of access to those people, which is nice. Have you
yeah.
gotten involved in your local ACI chapter at all?
Well, yeah, we just attended a ACI local chapter meeting in Spokane,
Yeah.
in a precast concrete manufacturing company, and it was a very good experience. I brought 4 undergraduate students there, and they really enjoyed having the tour of the entire site, entire company, and also introducing them to the industry companies. Really, I think really helped them with the job seeking and everything.
Hmm. Yeah. Are you getting graduate students involved with ACI or any undergraduates? I'm trying to get more
Uh,
undergrads involved.
Mostly undergraduate students.
Really? Okay, cool. Yeah, that's a good idea. Kind of giving them access to different industry folks for career connections and
Exactly.
building their network. Yeah.
Absolutely. Absolutely. Thanks again for joining us, and thanks to everyone for listening to this month's episode of Engineering Greatness. Join us each month as ACI brings together pairs of young professionals in the concrete industry to engage in intimidate, intimate conversations about their life and work. Be sure to subscribe to our podcast on Apple, Spotify, Google, or wherever you listen to your favorite podcasts. And for more information on the American Concrete Institute, visit us online at concrete.org. We'll see you next time.